Okay, so for today, we are doing proofs. We haven't done proofs in like literally 20 days because of all the hurricanes and everything. The last time we did proofs was 28, which was October 1st. Okay, so for today's thing, this is number 32. So at the top, put number 32 because all of your pages should be numbered. When we do a binder check, realistically, you should just be able to give me your binder without having to put in a bunch of papers. Realistically, it's just me passing back random papers and then you just putting those ones in where they go. But it should just like go straight in the binder, like in order. Every page should get a number. Which reminds me, the second piece of paper, which is like the worksheet, is number 33. So if you want, number it now. Put your name on both sheets of paper. So the reference sheet kind of breaks down every single theorem and postulate and all the nonsense that we could use for these. When you're doing proofs on your EOC or on the test, it's going to have a word bank or it's going to be a little drop down option. So you're not just making up this stuff out of thin air. Okay. So it should make sense. Some of you are going to be really good at this and some of you are going to literally have no idea what's happening. So the first time we did proofs, we did properties of equalities. So this is where I gave you a math problem and it's like, I subtract to both sides and then I divide to both sides. And it was very fun and it was very easy and it made sense. So that's the properties of equalities. The left side of your paper is segments, which is like a line from chapter 1. The other side also has the same theorems. If you look, it says properties of equality, properties of equality. So you can use properties of equalities for both of these. Angles are obviously angles. Okay. So one side's kind of like your angles and then one side's your segments, and they kind of sometimes repeat because sometimes the theorems will kind of go back and forth. So let's start with the segments. So down here, we have reflexive property of congruence, symmetric property of congruence, and transitive property of congruence. We talked about these before, but I know nobody remembers because it's been 20 days because of all the hurricanes. So reflexive property of congruence, this is where it's literally the same exact thing on both sides. It repeats itself. So in parentheses, put same. So if I said AB was congruent to something, it's literally the same thing. So AB is congruent to AB. That's why you never use this one because it's kind of silly, but sometimes they'll throw it in there. Symmetric property is the one that we used the most last time out of these three. This is where you flip it. So if I got 5 equals X, I could use symmetric property to say X equals 5. So if I say AB is congruent to BC, then I could say BC is congruent to AB. So I can flip my sentence and it mean the same exact thing. The last one that we talked about last time was transitive property of congruence. Transitive property is the one where we take out the middleman. Bless you. So we have like a middleman. And it's basically like, if I know X is 5 and Y is equal to X and Y equals 5, then I could say X and Y are equal because they all mean the same thing. So I'm going to say if AB is congruent to BC, and I know BC is congruent to like CD, I can remove my middleman. And does anybody know what two things I could set equal to each other? AB is congruent to CD. So what I mean is I can literally just like take out the common thing that they share. They both share BC. So it's literally removing the middle item. So that's technically old stuff. And then really the other ones are also things that we've talked about like in the past. So definition of congruence, what does congruent mean? Equal to. So if I say AB is congruent to BC, then it literally means that AB is equal to BC. So congruence literally means equal. So if I say something's congruent and then I say it's equal, definition of congruence, and it can also go the opposite way. If I know that they're equal first, then I could say after that they are congruent because equal is congruence. And then from chapter 1, what is midpoint? The middle. So we're still talking about lines here. So if I have a line segment, M is in the middle. So it says the midpoint of a segment divides the segment into two congruent parts. So if M is the midpoint of AB, if A is here and B is here, boop, 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 then I could say AM is equal to what? MB, because they are two equal parts. So if I put a little line on a little line, it means that they're equal pieces. Another thing we talked about chapter 1, which was a very long time ago, back in August, is segment addition postulate. So if A and B and C are collinear points and B falls between A and C, does anybody know what I could write here to represent the segment addition postulate? Let's say I say AB. What could I add to AB?
BC.
BC. And then what would it equal to? AC. So if they take pieces of a segment and add them together and it equals the whole distance, then that's just segment addition postulate. So this is all technically old stuff. We just haven't really done proofs with it. The angle proofs are literally the same exact thing, except they're angles. With angles, you just have a couple of extra things. So you have properties of equality, that's the same exact thing. Properties of congruence, that's the same exact thing. Definition of congruence is the same thing. If I know they're equal, then I can say that they're congruent. An angle bisector, does anybody remember what an angle bisector is? It splits in half. So this is a midpoint, but instead of on a line, it's an angle. So it's creating two equal parts. What is complementary angles? They equal to 90. So this specifically, I want you to put a plus sign and I want you to put a 90 because they have to have a sum of 90 degrees. Sum means to add. What about supplementary? 180. So we're going to add to make 180. So if they ever have like an equation and it's adding something, then it's complementary, supplementary. Definition of perpendicular means that they're using the word right angle. So if it says right angles, that's a perpendicular, which also means what? What's a right angle and what's perpendicular? 90, which is also definition of a right angle. Right angle has to equal to 90 degrees, which is like a perpendicular angle, which is also technically complementary angles. So they kind of fall into place. Complementary you're adding, supplementary you're adding, right angles equal 90, and perpendicular means a right angle, which means 90 degrees. They also have angle addition postulate, which is the same thing as segment addition postulate. You're taking a piece, you're adding another piece that's equal to the whole. And then there's some other things down here, vertical angles theorem, those are congruent. We're also going to be talking about what's on the poster, which is parallel lines cut by transversal. So today is really about the vocab. So if you're not really strong with the vocabulary that we've talked about this year, you might struggle a little bit, but we're going to be talking about alternate interior, exterior, corresponding, same side, interior, exterior. So, but it's kind of like a puzzle. So like you got to make it make sense. So let's get right on into it. So number 33. So keep this reference sheet out because you're going to want it. Let's go to 33. We're going to skip number 1, cross on number 1. That's the only one we're crossing out today. Okay, let's go to number, which one should we do? Let's do 6 is old. You guys should know how to do 6 and 7. This is like, should we start with 6? Let's do 6 to refresh your brains. So this is from number 28. This is old stuff. What do you put in the first part? The equation, so the given part. So negative 5x plus 2 divide by 7 equals negative 4. Where could you automatically put given? Right next to it in the first reason will always be given. Okay. Where could I put x equals 5 automatically? The last step. The last statement. Okay. So now from back in the day, 20 days ago, thanks to the hurricanes, what would be the first step for this? Multiply, because you got to get rid of the 7 technically. Don't actually write that, but you're getting rid of the 7. So you have negative 5x plus 2 equals what? Negative 28. And what did you do to get negative 28? Multiplication technically property of equality. So I'll just put POE, property of equality. Now, what would you have to do to both sides? Subtract 2. So I would have negative 5x equals what? Not 0. Negative 30, because you're subtracting 2 from negative 28. So that's subtraction, property of equality. And then what would be the last step? Division, property of equality. So anyways, that's the old stuff. Let's go to the new stuff. So for these two, I didn't give you the word boxes to choose from because like it's just solving equations. Why don't we start with number 2? So number 2, I'm given a line segment. So I'm using the stuff from the line segments. It says given E is the midpoint of DF, I have to prove 2 of DE equals DF. So 2 of DE equals DF. So twice of that. So I have all of these filled in. Now on your EOC, they're never going to have 6 blanks. Okay. It's going to be like 2 or 3 max, and they're going to give you the option. So what is going to be the first reason no matter what? Given. So right off the bat, you should be able to fill that in. So this one's a little tricky. So it says E is the midpoint of DF. So how do I know DE is equal to EF? They're telling me they're equal, but how do I know that based on these options? Definition of congruence. That's not even one of them. Of midpoint. So definition of midpoint literally tells me that the two pieces are congruent because I know it's a midpoint. It's telling me it's a midpoint. So by definition of midpoint, those two pieces are equal. So now it says DE plus DE, so 2 of these pieces, would equal to DE plus EF. We have addition property, transitive property, simplify, and segment addition postulate. It is not segment addition postulate only because segment addition postulate and angle addition postulate are taking the piece, the other piece, and equaling it to the whole. In this case, they did not do that. So not transitive. So it's adding. So it's addition property. Because what they did, if you look, you have DE and then EF, they're adding the same thing to both sides. So they're adding DE to both sides and they're adding, oh crap, I put it in the wrong spot, but they're adding DE to both of these sides. So now it says 2DE equals DE plus EF. So from 3 to 4, what did they do? They simplified because they combined the two DEs. So like x plus x is 2x. They just combined them to make 2DE. So simplify. And then DE plus EF equals DF. No. Segment addition, because they're doing piece plus piece equals whole. That's segment addition postulate. And then the last one's transitive property. The reason why transitive property is removing the middleman. So if you look at your proof, they're saying 2DE equals DF. So they're actually taking this piece and they're equaling it to this piece because they're removing the middle statement. So they take your two statements and they're crossing out that middle section, just squishing it together. So transitive property is removing the middleman. That one was tricky. Let's look at 3. Take a second. I'll zoom out just in case you need it. For 3, try to fill in a couple things. See if you can figure it out. 3 is not that bad. you should be able to fill out 3 spaces just by looking at the given and the prove. 3 spaces could automatically be filled out without even having to think about what the question's actually asking. So look at your given. There's 3 spaces you could fill out automatically. Okay, does anybody know first reason? What is it? It should always be given. Okay, so this one, if you're completely lost in the sauce, you should at least be able to get this. Okay, given, cross it out. Okay, now looking at the rest of the given, does anybody see anything else that I could automatically fill in without even having to think about the problem? Tell me one thing. N is the midpoint of MO. See how there's 2 things that are given and it also says given twice and you're like, man, that's weird. That's because they only used half of it in the first statement. So the other half, this piece, can go in the other given. So N is the midpoint of MO. Boop. Okay. What's the last thing? What's up? Okay, hold on. What's the last thing I could automatically fill out without even like having to think that hard? LM is congruent to NO. So the prove is always going to go here no matter what. So from that, I didn't even like literally have to read the problem. I just filled out what I know. So now I can cross out things that I know. I'm left with 2 options. It says M is the midpoint of LN. That's given. LM is equal to MN. Definition of midpoint, because that's, if it's a midpoint, then they're equal. N is the midpoint of MO because it's given. So how do I know that these 2 pieces are congruent? What would be 4's reason? Malachi, what'd you say? Definition of midpoint. Because once I know it's the middle, then I can say that they're actually equal to each other. Point. Boop. And then what's number 5? Equals NO. And then also they're using transitive property because they're saying if this is congruent to this, and I also know LM is congruent to NO, then LM and that are crossing out. Where is it? LM and MN. Is it what? Oh yeah, it is on 2. Let's go to the back. Let's try 12. We're going to do 2 more together. They're not too bad. Okay. So for numero 12, the pictures are going to look a little crazy. So don't get overwhelmed. We still have a word bank down here. So without even trying to like read the problem, what's automatically going to go in the first statement? The given. So I'm going to literally copy the given information, boop, boop, in that first little box. Does anybody remember what these 2 little lines mean? They're parallel. So it's saying C and D, those 2 lines are parallel. And then that's why it's like parallel lines cut by transversal, because they were telling me they're parallel. So I know 4 and 3 are congruent. I know C is parallel to D because that's what's given. There's nothing else I could fill in. I can't fill in my prove right here. So that's all I got. So now how do I know angle 3 is congruent to angle 1? What vocabulary word would match 3 and 1? I know they're congruent. What vocab word? Nope, they're not corresponding. Alternate interior, because it's technically parallel lines cut by a transversal. So it's a little angle and a little angle. So it's inside the sandwich and they're jumping across the transversal. So these are alternate interior angles. They'll start adding extra lines just to confuse your brains. So alternate interior angles are congruent. And you can shorthand your statements. I'm okay with that. Now they're saying 4 and 1 because transitive property of congruence. The reason why they're using transitive property is because 4 is congruent to 3, 3 is congruent to 1. So I can take out my middleman of 3 and say 4 is congruent to 1. What would have to go in 4's little box? So angle 1's congruent to angle 2. And how do I know angle 1's congruent to angle 2? Because they are vertical angles. And then same thing, they're saying 4 and 2 are congruent. The reason why is obviously because it's one last option, transitive property. The reason why though is because they're taking out the middleman, which is angle 1 and angle 1, and saying 4 is congruent to 2. If I know 4 and 1 are congruent, 1 and 2 are congruent, then that means 4 is congruent to 2. We're gonna do one last one together and then you guys can finish these. For number 8, there's a typo though. It's the only typo that's on the paper. So for number 8, one of the reasons needs to change. And can I move the paper? Is everybody done? Okay, so let's go to 8 really quick. Cross out alternate interior angles and put vertical. Whoop. So take a second, try to fill out all of this one. They're not that bad, I promise. This is the only one with a typo. I accidentally put alternate interior instead of vertical. So take a minute, see if you could fill out the entire proof. They're not that bad. They should like make sense in your brain. If you don't know the vocabulary, you're going to be completely lost in the sauce. Okay, let's talk about it. What's going to be the first reason? Given. Every single time. Given. Nice. Okay. What else could you automatically fill out without even thinking? 1 is congruent to 2. The reason why is because the proof is always going to be down here. The given's always the first one. The proof is always the last one. So now I just got to fill in the in-betweeners. So if it says angle 1 and angle 3 are congruent, how are these congruent? Ugh. Angle 1 and angle 3. They're what? They are corresponding. Corresponding is important. They're in the same spot, just slid down. Corresponding angles are congruent. And then 3 is going to be the only leftover math one, which is angle 3 is congruent to angle 2. Ooh. And if you look, 3 and 2 are vertical, so they're across from each other. So vertical angles And then the reason why angle 1 and angle 2 are congruent is because transitive property, if I know 1 is congruent to 3 and 3 is congruent to 2, then I can remove my middleman, which is angle 3, and I could say angle 1 is congruent to angle 2. Typically transitive property is going to be like one of the bottom ones. It's not always literally the bottom one, but it's going to be towards the bottom because you have to prove everything else before you can use transitive property. So if you want to work on the back, I think the back might be a little bit easier than the front. Work on the back first, use the people next to you, and then you can work on the front. There are no more typos. That's the last typo. So what's up? When he gets back, you can go. What up?
I feel my water after.
Yeah, you'll be third.